California spent $6.5 billion on a single bridge, and it's impossible to miss. That massive 525-foot white tower over San Francisco Bay. It took 11 years to build, and it's the most expensive public works project in California's history. But this bridge wasn't built for aesthetics. It had one high-stakes job: to stay standing when one of the most dangerous fault lines in North America finally snaps. But here's the secret. Before the first car even crossed it, components specifically designed to prevent a collapse were already breaking. California knew, but they opened it anyway. Since then, the bridge has kept failing in ways no one predicted. This is the story of how the most expensive bridge the US ever built became a project California can't stop repairing, and the structural gamble that's still sitting right under your tires. Most people have heard of the Golden Gate Bridge, the red towers, the fog, the postcards. But the Bay Bridge is the one the region actually runs on. It connects San Francisco to Oakland across the San Francisco Bay, carrying Interstate 80, the main highway artery of the entire Bay Area. 4.5 miles long, 10 lanes wide, more than 270,000 vehicles cross it every single day. More daily traffic than the Golden Gate. The Golden Gate is the icon. The Bay Bridge is the lifeline. Guinness has the paperwork. It's the world's widest bridge. Here's the number that sets everything up. In 1992, engineers estimated it would cost between $150 and $250 million to seismically retrofit the eastern half. The final bill came out to $6.5 billion, a 2,500% increase, enough money to build approximately 26 full-size bridges. California spent all of it on one span, 2.2 miles. And if you've ever driven this bridge, you've been part of that bill. Tolls went from $1 in the 1990s to $8 today. 30 years of Bay Area commuters paying for it, crossing by crossing. The bridge has two halves. The western section, the old suspension span built in the 1930s connecting San Francisco to Yerba Buena Island, was retrofitted and kept. The eastern half, running from Yerba Buena Island to Oakland, is what was torn down and rebuilt from scratch. The single white tower you recognize in every photo, that's the eastern span. That's what this story is about. Construction started January 2002. It was supposed to open in 2007. It finally opened September 2, 2013, 6 years late, billions over budget, and already carrying a problem that would not make the press releases. But to understand how a bridge this expensive could fail this badly, you have to go back to the night it all became necessary. October 17, 1989, 5:04 in the evening. The Loma Prieta earthquake hits, magnitude 6.9, epicenter 60 miles away in the Santa Cruz Mountains. Not even close to the Bay Bridge, but a 50-foot section of the upper deck of the old eastern span snaps and collapses onto the lower deck. One person is killed. The bridge goes dark for a month. But the terrifying truth came later. Engineers realized the entire structure had been seconds away from a total, catastrophic collapse. The Hayward Fault runs directly under Oakland. It's one of the most dangerous urban fault lines on Earth. In 1999, seismologists put the probability of a major Bay Area earthquake at 70% within the following 30 years. That window is still open. The decision was about survival. Retrofit wasn't enough. The eastern span needed full replacement, designed to survive the maximum credible earthquake over a 1,500-year period and keep emergency vehicles moving within 24 hours of an 8.5 magnitude event. So how do you spend $6.5 billion building a bridge that survives the next earthquake and end up with broken earthquake components before it ever opens? The decision to rebuild was about survival. What happened next was about something else entirely. The new eastern span uses a self-anchored suspension design, or SAS, a single asymmetrical tower 525 feet tall. Usually, suspension bridges have massive cables anchored into the ground on both banks, but this one is different. The main cable anchors within the deck itself, so the deck absorbs all that tension through compression. It was a structural system that had never been attempted at this scale anywhere in the world. When it was finished, it was officially the longest single-tower SAS bridge ever built. The main cable alone is made of 137 prefabricated bundles, each nearly a mile long, over 17,000 individual steel wires weighing 10.6 million pounds total. Why go experimental? The Oakland side geology was a problem. Deep bay mud made traditional anchor blocks enormously expensive. In 1998, this design won a public competition. People wanted a landmark. And that's where Governor Schwarzenegger enters the story. The original plan was a straightforward concrete viaduct, $1.4 billion, safe, functional, and totally unremarkable. Critics called it a freeway on stilts. When Schwarzenegger's administration took over, the push for an architectural statement hit high gear. The SAS tower became the centerpiece. Engineers raised red flags. They warned this design had never been built this big, that it would cost more, that it would take longer. And they were right. The price tag started at $1.4 billion for the simple plan, jumped to $2.6 billion once the SAS design was picked, hit $5.1 billion by 2005, and finally landed at $6.5 billion. To be fair, voters greenlit the signature span in a 2000 ballot measure. People wanted a skyline-defining icon. There was one more thing that got traded away when that decision was made: transit. The old eastern span carried trains. The new one has no rail capacity at all. That option was gone the moment the signature span was chosen. But the design wasn't the only choice that sent costs into the stratosphere. By 2004, the pressure to save money was reaching a breaking point, and that led directly to the next decision, the one that still makes people the most angry. By 2004, billions over budget, the state needed to cut somewhere. They chose to outsource the steel fabrication to China. They picked ZPMC, a state-owned Shanghai company that dominated the global market for port cranes. One problem? They had never built a bridge. Caltrans' own auditors flagged them as high risk. They gave them the contract anyway. $350 million. 50,000 tons of steel. The 525-foot tower arrived by cargo ship in 2010, built by a company that had never constructed a bridge. Before it even shipped, 15 former welders and inspectors went to the FBI. Their claim? Workers were being rushed so hard that up to a third of the welds were defective, covered up, re-welded on the surface, buried in concrete. Some of those welds are now underwater. They can never be inspected. Caltrans said it was impossible to hide bad welds from their inspectors. Tests came back clean. The FBI investigated for 8 months and closed the case without charges. The inspectors didn't back down. A California State Senate review later found that Caltrans had waived welding code requirements to accept ZPMC's cracks, calling it engineering judgment, and that managers had removed or demoted at least 9 engineers who tried to speak up. The project lead, Tony Anziano, was named in that report. He retired in 2015. No charges, no discipline. Caltrans' own head of materials testing testified that ZPMC treated requirements like suggestions. Independent UK experts concluded the cracking indicated serious disregard for procedure. Before any of this unraveled, a contractor offered Caltrans $250,000 worth of equipment to inspect exactly these kinds of welds. Caltrans said they didn't need it. The problem it might have caught cost hundreds of millions to fix, on a $6.5 billion bridge built for one purpose. No one went to jail. The savings evaporated. So many welds had to be ground out and redone on site that the cost-cutting move ended up costing more than it saved. The tests were clean. The case is closed. The workers who saw those welds still say it was a cover-up. The bridge opened, the speeches were made, the $8 toll kept coming. The weld story was over. but the bridge was about to reveal a completely different failure. It's March 2013, 6 months away from the hyped Labor Day opening. Workers start tensioning the anchor rods for the shear keys, the components that keep the deck from sliding sideways during a quake. One job. But as they start tightening them, 32 of the 96 rods snap, fracturing at the base. Workers had to abandon all 96, embedded in the concrete forever. The cause? Hydrogen embrittlement. The rods were installed in 2008 and left exposed to salt air for 4 years. The steel soaked up hydrogen, became brittle, and when the pressure was applied, it gave way. The warning wasn't vague. Bridge engineering standards had already flagged this rod type as unsuitable for wet, salt air environments for exactly this reason. That prohibition was on the books before the first rod was ever ordered. Those 32 broken bolts are now permanent. The state's workaround? A $5 million saddle system, a giant clamp to do the job the rods couldn't. The bridge opened September 2nd, 2013 on schedule. The saddle fix? Not $5 million, $25 million. Caltrans says the bridge is safe. Dr. Abolhassan Assenayassel from UC Berkeley disagrees. He's called it fracture critical. One major piece fails, the whole thing goes. He was surprised the federal government approved the fix at all. 270,000 people cross this bridge every single day. Almost none of them know what's in the concrete beneath their tires. 11 months after opening, the bridge had its first real test. In August 2014, the largest Bay Area earthquake since Loma Prieta hit, magnitude 6, centered near Napa. The eastern span shook. It held, with no reported structural damage. But a 6 on a distant fault is not a Hayward scenario. The bridge passed its first real shake, just not the one it was built for. In 2015, engineers found standing water in 95% of the conduit sleeves holding the tower's 424 anchor rods. They also found that 135 of those rods were never properly grouted because one contractor thought another had already done it. The fix? Seal the leaks and install massive dehumidification systems to keep the rods dry. But here's the catch. For this bridge to hit its 150-year design life, those dehumidifiers have to run perfectly without failing for the next century and a half. Then, in 2016, a chunk of concrete the size of a car tire fell from the ceiling of the Yerba Buena tunnel below. It blew out a driver's tire and narrowly missed causing a massive accident. Caltrans eventually found a dozen other spots where corrosion was literally eating the concrete away. And in 2018, they found something even stranger: microbial corrosion. Basically, marine bacteria in the bay are producing acid that's eating into the steel foundations. The lead engineers admitted that if this keeps up, the bridge won't be what they assumed it would be in 150 years. It feels like every year or two there's a new finding. It's a brand new bridge that's already acting like an old one. So, where are we now? The shear key rods, the 32 that fractured before opening, are still embedded in the concrete. They cannot be removed. The $25 million saddle system is now the permanent solution. Caltrans' official position is that the seismic function has been fully restored. Independent engineers say the replacement system works differently than designed, and its performance in a major earthquake has never been validated by a real-world test. The 424 tower anchor rods, the ones holding the 525-foot tower to the bay floor, are being managed through dehumidification systems installed inside the conduit sleeves, designed to keep moisture out and stop embrittlement before it starts. That fix works as long as those systems keep running, without interruption, for 150 years. The microbial corrosion and tunnel concrete issues remain under active monitoring. No projected end date for either. Meanwhile, in 2024, Caltrans opened up the western span's main cables for the first time in 90 years to check for internal corrosion. And the results of that examination still haven't been published. In July 2024, Caltrans published its most recent formal assessment of seismic safety across California's bridges. The Bay Bridge eastern span, 12 years old with broken bolts in its concrete and unresolved engineering disputes in the literature, is not specifically addressed. And the Hayward Fault is still out there, and seismologists put the odds of a major rupture on that specific fault at 33% before 2043, a fault-specific estimate separate from the broader regional countdown. In 2014, 11 months after opening, a 6 hit near Napa. The bridge shook and held. But a 6 on a distant fault isn't the test this bridge was built for. The Hayward Fault doesn't send warnings from 30 miles away. When the ground finally moves, what do you think happens? Let us know in the comments. If you want to see more Megabuild stories, subscribe. Thanks for watching.